Welcome back. In this lecture, I'm going to look at Google App Engine, which is a leading platform as a service cloud platform provider. The idea in Google App Engine basically is that it lets you build and run web application on Google's infrastructure. Applications on Google App Engine can be easily built and easily maintained, and it allows you to scale your application as your traffic and data storage needs rise with your users increasing and so on. So basically you don't have to maintain any server, etc., as we have seen in the previous lecture about basics of platform as a service. All you do here is you upload your application after you have built using the tools and technologies that are supported by Google App Engine. Since Google App Engine is a public PaaS platform, public PaaS cloud, it has a pay for use kind of a costing model. That is, you pay for the resources that you actually use. And typically there are no upfront costs that you need to incur for moving on to Google App Engine platform for your application development and deployment. All the resources that your application will use on Google's infrastructure, that will be very minutely monitored and measured. So you are billed according to what resources have been used by your applications. So you can control the maximum amount of resources which your application can consume, and accordingly you can plan the capacity in advance and so on. Besides, when you sign up for Google App Engine, you get decent amount of free quota. For example, you get about 1 GB of storage and reasonable amount of CPU and bandwidth to support a common simple web application. For example, serving around 5 million page views a month is almost free for you. You are billed only if you exceed the free quota limits. Some of the common features that it supports is, number one, it allows you to build dynamic web applications. So it supports several common web technologies which you can use to build your web application. And also it provides you persistent storage in which you can store your application's data, and it allows querying and sorting and transactions, etc., which are fairly common features whenever you are developing data-driven dynamic web application. Another thing is that it allows automatic scaling and load balancing of your application. And similarly, it offers you several APIs, for example, for authenticating users and authorizing the different pieces of your functionality depending upon who is the logged on user, etc. So there are APIs which support these kind of features that you have to build in your applications. It also allows you sending emails using Google accounts. To support efficient development, Google App Engine also provides a fully featured local development environment which you can install on your local machine. It simulates the actual Google App Engine environment on your local machine so that you can quickly build and test your changes iteratively, and then finally, once you're satisfied with whatever implementation you have done, you can push that application version onto the Google's infrastructure. Another feature that it provides is task queues, where you can trigger some piece of logic to be executed outside of a scope of a web request, because primarily Google App Engine offers you a web application development environment, but in certain scenarios you might need to process some work which should be done outside of the scope of a regular HTTP based web request. So for those kind of scenario, it offers you task queues which you can use to implement that kind of functionality. Similarly, you have scheduled tasks for triggering events at specified times or even regular intervals if your application so demands. So all these features are useful if you are building some business applications, and the APIs are fairly simple. So we'll look at some of these details in subsequent files as well. About the deployment environment in which your application runs, as we saw in a previous lecture, PaaS platform typically offers a sandboxed environment to its application, and Google App Engine also follows the same thing, where your application is given limited access to the underlying operating system. The idea here is that by using a sandboxed isolated environment, Google App Engine is able to give you as a developer a secure and isolated reliable environment which is decoupled from the underlying details of hardware, operating system, and physical location of the web application server. So as such, they are able to easily distribute the web requests for your application across multiple servers and are able to load balance and easily scale for meeting the demands of your application's load. Obviously, to allow this kind of sandboxing to be implemented, there has to be some sort of restrictions that are placed on your application. So some of the key ones are that your application can access other resources or computers on the internet through the URLs that are provided, and you can use email services as well. And similarly, if someone else has to connect to your application, they can do so only by making HTTP based requests on the standard ports. It is not allowed for your application to write to the file system or in any of the runtime environments. So you are not able to open any file streams, etc. that writes directly to the file system. However, your application will be able to read files, but only which your application has received as uploads. And in order to persist any data that your application has to process between the requests, it can use only the storage mechanisms provided by App Engine, which are like App Engine Data Store, Memcache, or some other services that it offers. And there is also a limitation on the time a typical request is allowed to take before it responds. So it's I guess about 60 seconds in any case. So your application logic should complete within 60 seconds in response to any given request. And also your application may not be allowed to start any sub-processes or execute any kind of code after it has sent the response back to the client. So these are some of the restrictions which, when you are building any kind of applications on Google App Engine, you will be required to consider. Now let's look at the data storage features that are available on Google App Engine. Data storage is typically required whenever you are building any meaningful business application. You have to usually store data between the requests, and Google App Engine provides three mechanisms to allow you to achieve the data storage. The first one is App Engine Data Store, which provides a schema-less object data store where you can do querying as well as atomic transaction. Second is Google Cloud SQL, which is nothing but a SQL database service for your App Engine applications, and it is based on MySQL RDBMS. And the third one is Google Cloud Storage, which you can use to store large objects and files up to terabytes in size, and you can access it from both the supported languages, that is Python and Java. The App Engine data store, the NoSQL schemaless data store that we just said, it allows you two different storage options, where you can trade off between the availability and consistency guarantees while setting up those options. There are important differences between the traditional relational databases like MySQL, etc. that you are probably used to, and the App Engine data store. In App Engine data store, the data objects or the entities, they have a kind or a type and some set of properties defined on it, and you can use queries to retrieve these entities or objects of a given kind or a type. You can filter it based on some property values, and you can sort them as well, and the property values can be of several types which are supported. And the data store entities are in that sense schemaless in the sense that the structure of these data entities is provided and enforced by your application, unlike you have in traditional relational databases where you will define a schema and a set of tables and their structure, etc. is predefined. Whereas in the App Engine data store, you may have different instances of a given type of entity to have different set of properties. You can use standard APIs, for example Java's JDO or JPA interfaces. You can use those ones or the one that Google App Engine itself provides in order to access the data from App Engine data store. And from the perspective of transactions, it supports the regular ACID semantics and also allows you to use optimistic concurrency control semantics in your application. Similarly, it has incorporated several other features. For example, whenever you are updating an entity in a transaction and simultaneously someone else is also trying to update the same entity, the system will automatically retry the transaction in a fixed number of times in such kind of scenarios to make sure that the data is not lost. Similarly, Google Accounts is another service that you can use in your application when deploying it on Google App Engine. You can use this service to authenticate users in your application, and your users can use their Google accounts to sign into your application and access the email address and other details which can be associated with your Google account. And often this saves you from the effort of implementing user management subsystem in your applications. That is where you have to register the users and maintain their profile and so on. This service allows you to leverage the Google accounts where these features are already implemented. Some of the other services are URL fetch, mail, as we saw briefly, memcache, and image manipulation, etc. Using URL fetch, your application can access resources from the internet using HTTP protocols, and mail service can be used to send email messages from within your application. A high performance in-memory key value cache is provided by memcache, and multiple instances of your application can make use of this. It is useful for storing temporary data outside of transactions. That is when you're not requiring any transactional features of the regular App Engine data store. Memcache can be pretty handy in such cases. And image manipulation service can be used in case your application have to manipulate images. That is, you want to resize, crop, rotate, etc. Images in several formats. For example, JPEG or PNG images can be handled easily by using this service. Often there will be scenarios when your application has to perform some application logic outside of the scope of a web request. In such scenarios, you can use task queues or scheduled task features which are provided by Google App Engine. For instance, you can configure some schedule such as hourly, daily, or on certain number of minutes to perform some task which will execute some piece of code in order to address the task. Now let's look at the architecture of Google App Engine instance for Java platform. Here you see several components in this architecture. On the left you have this admin console, which as a developer you are going to use in order to log on to the admin console for viewing various statistics about your different applications, as well as deploying applications, undeploying, etc. You can also look at the billing information about what resources you have used in your different applications. At the same time, in the services you have various type of components like URL fetch, user accounts, cron, memcache, and mail, etc., which are available to your application via the APIs that we have already spoken about. And similarly, you have data store and the appropriate API through which you can access the data store services, and your application runs here in a regular JVM. This is how a typical Eclipse-based development environment looks like for developing Java applications in Google App Engine. So it offers several features where you can access standard Java application templates and build the applications. This shows the console's log for deploy action from within the Eclipse IDE. In order to deploy the application from within the IDE, you will have to sign into your Google account and then access Google App Engine deployment console from within it. This is the Google App Engine admin console or the dashboard. On the left you see several options using which you can examine. For example, on the second item in the main head is instances. You can click on the instances link and see how many instances of your applications are active. Similarly, you can view detailed logs, per request logs, etc., version of your various application, and so on. And similarly, cron jobs, task queues, etc. At the same time, you will be able to access data store indices and data store views, etc. Let's look at the next screenshot, which shows fine-grained data store statistics. For example, on the left you see the storage space used by property type. So it's a pie chart. It clearly shows the different property types, how much space they have consumed. And on the right you have the pie chart shown by entity kind. So in this example there were two entities, one is person and another is greetings. They have been taking 4% and 1% space respectively. So this gives you a very fine-grained view into how your entities are using different resources so that you can tune your application. And this is the billing information. You can see how much of the resources you have used. So just to summarize, a PaaS platform typically eases the tasks of the developers, and Google App Engine has been targeted for this kind of a scenario where you don't need to worry about underlying infrastructure's management and maintenance. Basically, you are mainly focusing on your development activities where you code your logic in your applications, and you're not worried about, as I said, about the underlying operating system and other concerns. And the provider, PaaS provider like Google App Engine, they will give you the necessary APIs and application services such as storage engines, identity management, as we saw, asynchronous tasks, etc., and language runtimes, which are required for your applications to run. And PaaS provider takes care of the low-level issues. And there are several players. We have looked at only one, Google App Engine. Microsoft Azure is another one, and similarly VMware Foundry, Cloud Foundry is another option which offers PaaS platforms. So that's pretty much it in this lecture, and we'll see you in the next lecture. Thank you.